Semantic segmentation labels the background beautifully but merges objects together. Instance segmentation separates objects cleanly but ignores the background entirely. Each solves half the problem, and for years you had to pick one. Panoptic segmentation, introduced by Kirillov and colleagues in 2018, finally unifies them into one complete, coherent labeling of a scene where every pixel gets a class and, where it matters, an instance identity too. No pixel is left out, and no two labels overlap. Let's see how those two has become one map. Look, the cleanest way in is to watch a single scene get assembled into one unified output, region by region. The scene first has its amorphous stuff regions labeled by class. Sky, road, grass, water. These are uncountable background areas with no meaningful notion of individual objects. So the network simply paints each pixel with its category, exactly the way semantic segmentation would. There's nothing to separate here, only to classify. Then the countable things are detected and separated into instances. People, cars, animals, each discrete object gets its own identity. So two pedestrians standing together become pedestrian 1 and pedestrian 2 rather than a single merged region. This is the instance-style half of the job, handling the objects that semantic segmentation would have blurred into one. Now both results are merged into one non-overlapping map. Every pixel is resolved to a single answer, with no gaps left blank and no two labels fighting over the same location. The stuff and the things finally share one coherent canvas, and the final output gives every pixel a class, plus an instance identity whenever that pixel belongs to a thing. Quality here is measured by panoptic quality, often shortened to PQ, a single score that rewards getting both the labeling and the separation right at the very same time. Now, to really feel why this unification matters, put the two older tasks on one side and panoptic on the other. Semantic or instance segmentation on their own each cover only half the scene. Semantic handles the background stuff but blends objects together, so you can't count them. Instance separates the objects but leaves the background unlabeled. And because its masks come from independent boxes, two of them can even overlap on the same pixel. Panoptic segmentation refuses that trade-off. It fuses stuff and things into one map, assigning every pixel a class and every object an identity in a single, non-overlapping result. Nothing is left out and nothing is counted twice. So let's lock in the three ideas that define this task. First, it unifies semantic stuff with instance things. One model handles both the uncountable background you only need to classify and the countable objects you need to separate in a single coherent pass over the scene. That formal distinction between stuff and things is the idea the task really contributed. Second, every pixel gets exactly one class, plus an optional identity. Background pixels carry just a category, while object pixels carry a category and a unique instance number, and no pixel is ever left unlabeled or double-claimed. That one pixel, one answer rule is what makes the map coherent. Third, the result is one complete, non-overlapping scene map. There are no gaps and no conflicts, every pixel resolved to a single answer, which is precisely the full understanding a self-driving car or a robot needs, knowing the drivable road and counting every pedestrian on it, all at once. All right, let's gather the essentials to carry away from this one. Panoptic segmentation unifies semantic and instance segmentation into one complete labeling where every pixel gets a class and, where relevant, an instance identity. The key distinction is stuff versus things. Amorphous stuff like sky and road is labeled by class. Countable things like cars and people are separated into instances. Measured by panoptic quality, it produces one non-overlapping map, exactly the complete scene understanding self-driving cars and robots need. Ready to connect the whole segmentation family together? We teach the entire computer vision path in plain language over at standarity.com. Join us there.